In this section, we are going to see different properties of logarithms, and they basically follow from properties of exponential functions, since a logarithm is just the inverse of an exponential function. So I'll show you what I mean by this. So I'll have two columns here, okay, where here I'm going to list some properties of exponential functions or just exponents, okay? And on the other side, some properties, corresponding properties of logarithms. Okay, and basically everything is related to the fact that if I take an input x and I apply a function, let's say f of x, which is the exponential function b to the x, well, of course, I'm going to get b to the x here. And if I, or maybe to make this less awkward, I could put a for the input, and then this would be b to the a for the output. And if I perform the inverse function, I'm going to come back to where I was before. Now, the inverse function is noted as log in base b of x. So that's just a notation, right, for the inverse function. It's just because this inverse function for the exponential function is famous that we've given it a name. So one thing that, so for property number one, we know that we've got this identity, b to the 0 is equal to 1. So in other words, 0 is sent onto 1 through function f. Okay, so that means that through function f inverse, 1 is sent onto 0, right? That means if 0, 1 is a point on the graph of f, 1, 0 is a point on the graph of the logarithm, right? So that means what? It means, in terms of logarithm, it means that the log in base b of 1 is going to give us 0. So this is something we can just frame, okay? So you see how these completely match. So we haven't done any mathematics. We just rewrote the property for exponentials in a different way using the logarithm, using the inverse function. So this is property number one. So maybe as an example, we know that 5 to the 0, that's 1. So the equivalent of that would be log in base 5 of 1 is 0. Or in other words, 0 is the exponent. We call that logarithms and exponents. It's the exponent to which you raise 5 in order to get 1. Right? So no big mystery here. So this is number one. Number two, property number two. So for property number two, you'll remember that if we've got a function and its inverse, f of f inverse, actually, no, it's the other way around that I wanted to look at right now. F inverse of f of x will give me back x, right? One undoes what the other does. So I can replace x by a if you prefer, okay? Which is sort of what I have on my diagram. You see, if I've got a, if I do f first, I'm going to get b of a, and if I do f inverse, I'm going to come back to a. So let's rewrite this identity here with our function. So this is f inverse of, what's f of a? F of a is b to the a. Okay, and that's going to give me back a. And what's f inverse? It's log in base b. So what we get here is log in base b of b to the a is going to give us back a. Okay, so this is just stating this identity here. So this is a general property for a function and its inverse. It's not just something that applies to exponential functions or logarithmic functions. But in our case, this is what it says. Log in base b of b to the a is just a. And it makes complete sense if you think of a log as an exponent. So that just says that a is the exponent to which you raise b in order to get this guy, in order to get b to the a. So it's just saying that b to the a is b to the a, okay? So nothing very deep here again. It's just using our notation to rewrite this out. So for example, if you've got log in base 5 of, let's say, 25, okay, well, you can say, oh, 25 is the power of 5. So this log in base 5 of 5 squared, that's just 2. Okay, if I have log of 0.001, this is log in base 10, right? If I didn't write anything for the base, it automatically means it's log in base 10. 0.001 is 10 to the minus 3. Oh, that's just minus 3. Okay, and it makes complete sense that, for example, here it's 2, because this just says, okay, if I read this, okay, it says, to which power do I need to raise 5 in order to get 5 squared? Well, power needs to be 2. Okay, so again, nothing too deep here. So this is actually not following necessarily from a property of exponents. It's just a property, a general property of a function and its inverse. Okay, so property number 3 is sort of the other way around. If I do f of f inverse of a, I'm going to get back a again. Okay, so if I read this, this means f of log in base b of a is going to give me back a. And f of x is b to the x. Right, so this is going to be b to the log in base b of a gives you back a. So we are going to frame this again. B log in base b of a, which is the exponent here, gives us back a. So this looks kind of awkward. Let's look at an example. If I do 5 log in base 5 of 3, this is just going to give me back 3. And this makes sense again because this, the log, remember, it's an exponent. So it's the exponent to which you raise 5 in order to get 3. So if you raise 5 to that exponent, you're going to get 3. So this is just, again, a way of saying the sentence I just said, but written in mathematics. So we won't use that third property very often. So the second one is the one that we'll find more often in the problems. Property number 4. It's not, well, it's kind of a property, but again, it doesn't follow. This is not one that follows necessarily from, well, it kind of follows from an exponential function in some way. The exponential function, let's say I consider one where b is above 1, it's like that, right? So so if I have y equals b to the x, okay, and even if b is less than 1, it's going to be a one-to-one function, right? When you reflect this across the line y equals x, you're also going to get a curve that represents a function that's one-to-one. So also, the function y equals log in base b of x, okay, which will look like this if b is greater than 1, is one-to-one. Okay, so one-to-one means that if I have f of a, which is equal to f of b, okay, same y values, the x values have to be identical. Why? What does it mean that? Imagine you have a function that's like this. This is not a function that's one-to-one because for a given y, okay, which I illustrate with, like, let's say y equals k. So if y is k, there are two x values that give me a y value of k. So that's not a one-to-one function. So for a one-to-one function, it needs to satisfy the horizontal line test. For every single y, there's only one x that has this y value. Okay, so those are two y values. So if they're equal, okay, their inputs have to be equal, because if I have two different, if a and b are different, I would have two different x values with the same y values, and that wouldn't make the function one-to-one. So for one-to-one function, we've got this identity. F of a equals f of b means a is equal to b. So I can sort of get rid of the f's on both sides. So this reads for our logarithm that if I have log n base b of a is equal to log n base b, oh, I shouldn't write b here, maybe. That's why I'm going to use x and y. Log n base b of y, that means that x and y are the same. In other words, I can get sort of rid of the logarithms on both sides. This is also true for exponential functions, by the way. So if you've got b to the x, which is equal to b to the y, then automatically x needs to be equal to y. So this is the second, the fourth property. We use this sometimes just to simplify an equation. So if I have log of 5x, notice I didn't write the base, it means the base is 10, is equal to log of x minus 2, okay? Because the logarithm is one-to-one, I can sort of get rid of the logarithms, okay? So I can say that 5x is the same as x minus 2, and then just solve for x now. So this is completely equivalent. And solving for x, I would get that 4x is minus 2, and x is minus a half. Okay, so you see how that goes. So this is similar if I have here, if I have 5 to the x minus 2 is equal to the 5 to the 3x minus 1, I can deduce that the exponents have to match. Okay, again, because my function is one-to-one. So this would give us 2x is equal to minus 1, and so this is just a coincidence, x is equal to minus a half again. So I'll stop here, but there are more properties, so we'll do that in a second video.